So and also start recording here. Okay, so looking at the addendum, just to tell you what's coming next week. Oh, it's only smart pointers. Smart pointers and multi-threading, yes. So we're going to do smart pointers. If we can finish multi-threading, we'll do it. Multi-threading following, covering what we have in our notes is very easy. It's 2 seconds. But down to up to this point, I always teach multi-threading the manual way, like the way you can actually do multi-threading without using the STL. So I will try to cover that too. So we'll see. So the very first thing we're going to talk about will be smart pointers. Raw pointers, please study it yourself. I talked about it at the beginning of the semester. We had a session for the pointers, right? So you know what they are. Please go through them. See if you have any problems. Use ChatGPT or whatever you are using, or Copilot to learn it. So you are coming, I'm going to jump right into smart pointers. And then after smart pointers, we'll talk about multi-threading, and you're going to have a quiz next week. Okay? So I don't know what I'm going to, probably it's going to be on files. But you're going to have a quiz. I'll try to have 3 quizzes instead of 2. So it's going to be smaller quizzes, but you have a more chance to do better in it. Anyways. Let's start. So I don't want to save that. I'm just going to remove it and delete. Okay. We talked about files and how iStream and OStream are driven, IFStream and OFStream are driven from iStream and OStream, and how everything that you do in text version of iStream and OStream, which is see in and see out, work exactly the same way in files. We had some examples on it, but at the end we ended up with a binary write. So I'm going to go through the binary write, start with writing files in binary and explain how they work, and then we're going to see how we can use it and what is the difference between binary and text file read and write. So what I'm doing in here, I'm opening an OF stream. Sorry if I'm sitting over here. If I bring this up, the screen is not going to be visible, so that's why I'm sitting. So as you see over here, I opened the file. I created a file called numsbin, okay, for writing, because it's OF stream. It's going to be for writing. And I'm writing over there iOS binary. And you can separate these things, and later on you'll see that I can add more stuff over there. But iOS binary is essentially to specify that I want to write in binary format. If you write that in Linux, it doesn't make any difference if you write it or not. In Linux, everything, or Unix, everything is binary. We don't have a non-binary file. Text and binary are the same, but in Windows systems, you have to write binary for it to become binary. Remember that, okay? So write it anyway, and that becomes portable, which means in all platforms it works properly. Then I'm creating a vector of doubles. So essentially 4 double values are in there, right? Then I loop through the doubles, and I call the write function of file. So write function of file essentially only needs this address of what I want to write and its size, okay? Address of what I want to write and its size. And it's still a question for me. I don't know who wrote this thing and what. I'm 100% sure there is a reason behind it, But if I would have written this function, I would have used the void pointer over there. So nobody had to cast anything. But it actually receives a constant character pointer. Why? Because the smallest unit of memory in C is a character, which is a byte, right? They call it char because coincidentally it's the same type of an ASCII code, so it can be used for characters, but it's actually a byte. So you send the address of an array of bytes, which is a character, and the number of bytes that you want in memory. It gets that one and dumps it exactly as is into a file. So when I'm saying address of V, essentially, because I'm writing a for loop over there, in that for loop, V becomes, because it's a reference, it becomes a double. It's auto, right? So V is a double reference of the first element. So I'm saying, give me the address of the first element and size of V, which is essentially a double, 8 bytes. It treats that double as an array of 8 bytes and writes it byte by byte into the file. And therefore, an exact copy of the memory pattern of the double will go into a file. Now, because it's character, and now C++ is type safe, I have to cast that into a constant character pointer. And the only way that I can cast it, that it compiles, is through a reinterpret cast. Because when you want to change types of the pointer, it has to be reinterpret cast. So I'll go reinterpret cast to constant character pointer. What? Address of V. So address of V is now casted to a constant character pointer and size of V. So when I write this beautiful program of mine, when it compiles, the output is nothing because I'm writing a file, but when I open the file over here, this is what I'm going to see. Some garbage over there, which is not garbage, it's just the memory pattern of those doubles that I have written. So there is exactly 32 bytes in there because I have 4 doubles, 4, 8, 32. There are 32 bytes over there. These 32 bytes are back-to-back those doubles that I had in memory. We good? All right. Yes?
What's the first bit? The 000100020? Is that the address?
Yes.
Okay. And then following is the binary pattern?
Yeah, so it's 0. When it's 0, 0, it's 0. It's 1, 0, it's 16.
16?
It's hexadecimal.
Oh.
So that's 16, and then 20 is 32.
Oh.
Okay. So this is a memory dump. So essentially shows, and you see over there, it says 60 FD. So 6D is essentially a bit, 6 is, I think, goes 4, it becomes a 110. Okay? So that's essentially the bit pattern. So that's 6D. So the first 4 bits is 6 hexadecimal. The next 4 bits is D hexadecimal. That's the bit pattern of that byte. So each byte over there. But that's not important. I just showed you so you see that's the case. So essentially, one, two. So this is actually your first double in there. If it was an integer, this would have been your first integer. And this would have been your second integer. And the third, it keeps going like that, okay? Anyways, but that's not important. So now I created this. Now let's read it. How do I read it? The exact same way. But the difference over here is that now I don't need a vector because I'm reading double by double, one double at a time from the file, right? And I want to print the value. So what I do, I first opened the same file in binary format for read. Now it opens for read. Now I'm going to say while file is not in a failure state. Then I'm going to say file.read. It's the exact same thing like write, but in reverse order, which means instead of a constant character pointer, you pass a character pointer to it so it can write into it. So I'm casting the address of that double into a character pointer and pass it to read. So read thinks it's an array of bytes. How many bytes? Double size of bytes, which is 8. So essentially reads 8 bytes from the file blindly and puts it in that array. And therefore, double will get the value it had when you were writing it. And then it's going to write it down. So if the file didn't fail, I'm going to write it down. Otherwise, I'm going to say end of file. And therefore, when it runs, it's going to go like this. So how small it got? Why? Okay, so let me bring it over here. Okay, and okay, so let's go through it. So it's open, and as you see, V is garbage. File was okay. It reads the first one, and now V is 12 point something. You see that? And it prints it out. And now it reads the next one. The next one, 10, 11, 12, 13. Now it's not a failure. Still, because it's as if I close my eyes and I walk to the wall. And I go 4 steps. I go 1, 2, 3, and 4. If my eyes are closed, I don't know that I'm in front of the wall. For me to fail, I have to try to get the 5th one, and I say fail. I can't. It's the same thing. It reaches to the end, so this is not a failure until it hits the read. As soon as it attempts to read, that's the time it fails and says end of file. Then it goes out and comes down, and I'm done. We good? Are we okay? Now, why? This is crazy because I could just write the numbers, and that would be nice because I could actually see what I have written over there, right? The difference over here is that now I have equal size for the record. Each double is exactly 8 bytes. Okay? Now I can do something like this. Take a look. First, let me stop it. So let me go to write a little. Dude, what's going on? Oh, Windows. Oh, Windows. Okay, so now we are getting introduced to a function called seek. Now seek, this function exists in iStream and IFStream and OFStream, both of them. Okay? So essentially seek says, where should I take action next? So if you seek to a location in the file, you do a read, it's going to read at the location you seeked to. And if you want to do a write, it's going to do a write at the location you seeked to do a write. Be good? Now. Seek has 2 different overloads. You see over there, I'm putting a question mark. I'm putting seek question mark. The reason is that they couldn't write the seek with the same name. They could, but then it would have been hard to call. So what they did, they said, we're going to create 2 different functions, seek P and seek G. Seek G is to seek to get to read. Okay, again, I would have written seek R, but they wrote seek G. So seek G means seek to get, seek P is to seek to put. So essentially to write. Okay? So when you seek, you have two choices. Either put an absolute address of the file. So if you put 25, it means go to the 25th byte of the file. Now if it's seek G, it means the next read will happen at byte 25. If it's write, the next write will happen at byte 25. That's number one, easy breezy. And the type you put in there is stream pose. Stream pose is like size T. It's a positive number. It cannot be negative because it doesn't make sense to say go from the beginning of the file 3 bytes back. It doesn't make sense. So that's the first version of seek P and seek G. Seek gets another overload for G and P both with something that receives 2 arguments. The first argument is of type stream offset. That is a regular integer, which means it could be minus or positive. Why? Because you're saying seek from which location. That from could be either iOS beginning, it means seek from the beginning, it means from beginning go forward, or you can say seek end, it means from end how many times I come back, how many bytes I come back, or you say seek current, it means from current location, should I go further or backward? That's where the value can be negative or positive. So if from current location, you say 2, it means from current location go 2 bytes forward. If from current location you say -2, it says comes twice back. Of course, for beginning, you shouldn't use the negative one. It doesn't make sense. And for end, you shouldn't use the positive one. You should always use negative. It doesn't make sense. So what am I doing over there? At line 18, I am saying I open the nums bin. Okay? At line 18, I'm going to say file. Because it's IF stream, I'm using seek G. If it was OF stream, I would have used seek P. Now, if you use F stream, if I had F stream over here, you could use both seek P and seek G because it's child of both. This is scenarios where you want to read from a file, see what it is, and then modify it, change it, okay? But this is not the case. So I'm doing a seek G. I'm saying go seek G to the end 0 bytes backwards, which means stand right at the end. Now we have another function called tell. I should have written that one. I didn't write over there. There is another function over here called tell that returns a stream position. What tell does, of course, that question mark is either G or P. Sorry, the cell phone has to be on. I apologize. Anyways, so tell G tells you what is the current location. That tells you what is the current location. So whatever location you're at right now, if you read 5 records, each record is 20 bytes, you do a tell G after reading 3 bytes, that will be 60 because you read 60 bytes. It tells you which location of the file is we are standing at now. So at line 20, I'm going to say seek G to the end, then I'm going to say file size is equal to file.tellg. Because I went to the end, if I tell you where you are, it's going to show me the size because that's the end of the file. Or I can say divide tellg by size of a double. Then I will know how many doubles I have in the file because that's what it is. So let's run it one by one and go through it and see what it is. So file is 32 bytes, and I have 4 doubles in the file. We good? This is going to be in your quiz, by the way. Okay? I'm going to tell you, write a program that displays the size of the file. This is a perfect question. I'm going to say, write a program that runs like this on a command file. Size, space, file name. Write the program. So you need to receive the file name through the argument list, open the file for read, do a seek thing, show the size, and that's what it is. And if the file doesn't exist, you're going to say file doesn't exist. So that's going to be a good program to write for a quiz. Somebody remind me of that because I forget. I have to go listen to the recording later. Okay, so that's that. So now I'm going to say seek G, size of double multiplied by 2. What does it mean? I'm saying go from the beginning of the file to the size of 2 doubles, which means it goes to the beginning, skips 1 double, skips 2 double. So now it's standing at the edge of the 3rd double, right? Now if I say actually, whoopsie, so I say seek G. Now if I say go with a read and display, it's going to show 12, 10, 11, 12, the 3rd double that I saved. Now I'm going to say, go back to the beginning, seek G0, read and print. That's the first one. Now I'm going to say, from the end, go minus size of a double. You see I static cast to stream offset and I put a minus in front of it, size of a double. So I'm going to say go backwards once from the end, which means that's going to be the last double. So take a look at this. Please appreciate the fact that I did 3 reads and I read 3 things from 3 different places in the file. If you had to do that with a sequential file, first you had to write a huge program. You had to loop through one by one, count how many things until you get to that point. You had to check for delimiter, all that crap until you get to the point that you want to actually read it. But this, like that, it's as if I'm reading 3 things. This is called random access to a file because you can randomly go anywhere in the file. And this is only possible if either you know where something is saved in a file or you have equal size for all of the records. I'm going to demonstrate soon. We good? Are we good? We okay? So that's that, and let's get up. Now, oh, this is the one, not that. Sorry. Don't look at this. This is the one. Yeah. So let's set this as start, up project, and start a project. Okay. Take a look at the employee. You see the employee? Very simple. It has salary, employee number, and the size is 52. Okay? By the way, you want to break before we continue, start this, before we continue? Or you want to finish early? Finish early? Okay. Because I see 3 people are in deep sleep. They're, I just want to make sure that we're good. Yes? You can watch the recording, right? All right. Okay. And any questions, let me know. Okay? So, so this employee thing, he has salary, it has employee number, and has name, and everything is enclosed inside the employee. There are no resources in here. Everything is in the employee, right? So what happens over here, and as you see, I have an operator less than over there set for this. You'll see what it comes for later on. When you save a class like this, a snapshot of this class, into a file, No matter how many methods you have, the size of the class always remains the same. Why? Because adding skill to something will not add to its weight. If I learn a new language and I can now speak, I'd say in Spanish, I'm not going to weigh more. It's my knowledge. Knowledge doesn't have weight. That's what it is. So how many things a class can do will not add to its size. Only its attributes will. We're good? Okay? So now, what I'm going to do over here is this. I'm going to as you see, create 19 employees in a vector, and one by one write it into a file. So I'm reinterpret casting every single employee in that line, and to the size of E, I'm going to write them one by one in a file. We good? Okay. So when I do that, there we go. So it ran. Now I'm going to take a look. This is my file. As you see, you can read the characters in there, so you know the first one is Homer, but you cannot read. So this is the H over here. Take a look. From here, and it goes right probably to somewhere around, I don't know where. So something like this. So this is the name, and the rest is all empty and garbage in it. But these values over here are the attributes, actually, that I had over there. We good? And it's like that. So you can't see it, but they all have exactly the same size. If you see, every name starts exactly at the same location, which means the size of each record is identical to the next one. Because of this, now I can do something like this. Now this is where magic happens. First, I can just write a loop back exactly like this. You know, that I can just create one employee, one by one, read and print. I don't want to do that, like I did for the doubles. Please, let me see if I have it over here. I don't think I have it over here. Add. Give me a second. So this is binary file iterator, binary file. Yeah, so remember that code that I had. Let me see if I have it over here. Remove. No, I don't have it. What do I do? I'm going to just, let's add a new file. Add new file. Let's call it, I think I'm going to call it C composite read binary. Okay, so this is exactly the code that I had for that double that I went back and forth. Exactly that. The difference is that I changed the employees to the double to an employee. So I'm opening the employee bin, I'm seeking to the beginning, then I'm seeking to the second, and I'm doing exactly like that. So if you look at this, you will see that it runs exactly like the other one, which means when I go through it, it's going to open the employee, go to the beginning, and tell what is the size, and how many employees are in a file, 19 of them, and this is going to be the third one. and this is going to be the first one, and this is going to be the last one. So as you see, exactly the same. It doesn't matter what you have, a double or a composite time, they all work the exact same way. Are we good? So that's reading manually as I read myself, but I can use magic for this too. Look at this. Remember iterators, right? I can have a vector and can have iterators pointing in vectors, and I can copy one vector. So if I want to create a second vector copy of the other one, I can say that I can create an iterator to the beginning and end of the vector that I want to create, and I create a copy for the second one, right? Look what I'm doing in here. I'm creating ifstream file employee bin. From the iterators, from iStream file, I create an iStream iterator. It works exactly like an iterator to an employee. I'm going to call it iStream iterator, and I'm going to say initialize it with the beginning of the file. So essentially, that iterator points to the beginning of the file. Then I'm going to create a second iterator of type employee iStream, and I make it empty, which means nothing, which means end of the file. Then I'm going to say create a vector of employees, EMP, starting from II, ending with EOS. And like that, it reads all the file into the vector. I don't even need to do read, because it wants to copy it one by one. Copying, which means it's going to start from the iterator, go to next, go to next, go to next, and and that's going to start reading it using standard template library. Now I can say employee and employees, go through that employees and show them all. I can pass all those things to it and sort it. Why? Because I overloaded the less than operator. Since the less than operator is ordered, the STL algorithm can sort it. And then I'm going to print it. So it works the exact same way. Like I literally can run this. Control V. Oh. Z, Control Z, Control Z, there we go. Control F5 and run it. Oh, I have to stop it first, sorry. And run. And there you go. Easy breezy. Okay? So that's that. And so now that we have this, let's actually do something else. And in here, I'm going to go to that employee thingy. Yeah, so let's see, as you see over here, I'm sorting on salary. So you can change this, and you can sort on anything you want, on their salary, on whatever you want. Anyways, or you can simply write the sort yourself, the sort that accepts a lambda, and get two employees and compare them any way you want using a lambda. Very simple, doesn't make any difference. Anyway, so that's that. And this is using iterators. And finally, set a startup project. Look at my employee now. Now this is a tough one because this doesn't have the name inside. This employee actually has the data outside of his scope. It's a class with resource, hence the rule of 5. The other one I didn't need to do anything because everything was enclosed. This one, it has the rule of 5. Now because of that fact, its read and write cannot be the same. If I write it like I did for the previous one, what it will do, it will simply write the address of the name that is currently in the memory somewhere. And 2 days later, when I'm reading the file, it's going to tell me 2 days ago where the name was in memory, which is no good. So for this, I have to do the tough thing. And this is where these two read and writes come. Now, please pay attention to this. You want me to talk about this the next day? I'm not getting the vibe that people are following, as if I'm talking like Anybody wants me to continue? Anybody wants to finish and the next day continue it? Nobody's saying anything. Okay, let me be done with it. So, this is an employee. And the employee of mine has a name in it, and the name is somewhere in memory. Actually, let's do something else. Whoa. The name is somewhere else in memory. Obviously, when I'm actually saving these names, I can put everything in a file that all the names will go through, and there's no problem with it. So when the file is being saved over here, I can do a shallow copy and put everything that I have inside the name right over here. So essentially this will go here, no problem. But what do I do with this? If I put it over here, one is long, one is short, it's not going to work out. So the second one that I have, that is, for example, the second one that I have, that is, for example, this one, will have a different size. Will have a different size of name, longer than the other one. So what do I do? For that, I will create another file, and I keep the names in some other file. So I save the first one over here. For the second one, I will do this. I'm going to say, okay, I have this name, so that name is going to be this long. I'll put it right here. That's the first name. Oops. Sorry, that's the first name. So this is the first name that I saved over here. Now, to remember what it was, first, I'm going to put the first location. So I'm going to say, where is the location of that thing starting? So essentially, I'm going to put the location that it starts. Right over here. And I'm going to put the location, so essentially the location that it starts is going to be a small integer. In this case, it's going to be 0. I'll put it right over there. Then I'm going to put over here, what is the length of this? So I'm going to take this length, whatever it is, and I'm going to put that length right over here. So I not only save the body of the thing, but I put the name in the other one. I put at the bottom of the class where the name is, and I'm going to say what is the length. So for the second one, when I'm actually saving, this is where the second instance is going to go. And this is where the name is going to go, because the name was bigger over there, right? So in here, I'm going to first put this value, where it's saved, right over here, And then I'm going to put the length of it, which is much bigger, over here. So after each class, I have the constant thing, and I have the data for where the name is in the second file and how big it is. But as you see, the size of the records remain the same. It's a class and 2 integers, a class and 2 integers, a class and 2 integers. So for this, I need to create a write that accepts 2 files. One, the objects file stream, the other one, the name file stream. And I pass it to write. So the write of mine will act like this. Take a look at the write. First, I check to see where is the location of the name. Remember? So let me just bring the drawing back. Whoa, I have to come lower. So this is the write. Okay. Okay. So now what I will do, right in here, I will see where the name is, and I hold it at name location. So essentially where the data is going to go. Then I'm going to see what is the length of the name, so I know what the length of the name is going to be when I write. Then I write the name in the file, so the file is written. Then I write the class, which is address of this. Then I write the location. Then I write the length. Therefore, these 3 are all written. This one, and this one. All 3 will be written. So essentially, it's going to be this. That's that one. This is the location that's going to be written. And this is the length that's going to be written. So every single time it writes, I write everything and I keep track of it. So the next time when I want to read it, what I can do, I simply get the 2 files. I create 2 variables for location and name. First, I will read the object. Then I'm going to read the location. Then I'm going to read the length. I'm going to allocate enough space for the name. Then I'm going to seek to the location of the name. Then I'm going to read exactly that much name into the allocated memory and null terminated. And the class is rebuilt. So essentially, my read and write will be like a copy constructor. All right? So writing something like this, if I run the program now, and write everything over here is the underline employee bin, you will see that this is the employee bin, which there are no names in it. And this is the name bin, which is only names. And each one has different size, but they are back to back. Do I need to have a delimiter? No, because each one of the places over here is recorded in the file, and that file have access to every location that it has, therefore it can be done. Your responsibility to go and use the read method and read them one by one, see if it works. Walk through it and print it out, see if it works. Good news, this is not going to be in the test because it's not covered by, it's not in our curriculum. But this is something you need to know. This is called random access. And what we had over here, you do databases, right? When you do database, you create a table, right? The table has a primary key, right? Primary key is essentially something like this red one, where you have access to where the file is. The information is over there. Primary key has, it specially creates what we call a hash formula for it. From that, it can go and actually find the data that is in a table very quickly. This is how it's done. So this data, you cannot find stuff in it very easily because they're all mishmashed. But the key for their location and their information, they're all in the other one. This becomes the key, that becomes the data. Okay? Anyways, just know it. But the other one, where we wrote the whole class without resources, you need to know that. Questions? Suggestions? Objections? We are done. Have a good day.